Well, thanks a lot, Damien. Yes, welcome to our little talk on leveraging semantic networks at Deutsche Bahn. First, you might ask, what is Deutsche Bahn? We are one of the world's leading mobility and logistic companies. The people over here in Germany might know us as the train company, even though we are active in different countries and outside Germany. Within Deutsche Bahn, there is a company, DB System, and we are basically the driver of digitalization for all DB Group companies. You can think of us as the IT department of Deutsche Bahn. And again, within DB System, you find the team Infragraph Analytics. We've been working on data integration since March of last year. We are 10 members, and I joined the team around March of last year. Before that, I was a consultant and freelancer working mostly in the internet and web field for about 25 years. And I've been working for about 10 years with graph databases, and that is one of the reasons why I came to DB System. So it's all about trains, really. Let's have a very short look at the history of rail operations in Germany. It all started basically about 200 years ago with a little train called Adler going from Nuremberg to Fürth. This is pictured down here in the left. And since then, quite a lot has changed. The trains have changed, they have become more modern, and up here you see something similar to the current designs of our trains. And not only have the trains and the infrastructure, meaning the railroads and the network, changed, also the ways in which we manage those systems for our customers have changed. With the introduction of computers and databases, of course, lots of systems have been built within Deutsche Bahn, which made things much more easy, but it also brought one problem with it. We have many systems talking about the same things. I just get the information that you actually can't see our presentation. Is that correct? Damien? That's unfortunate. Okay. Thanks a lot. I got the information from the audience. Okay, so sorry about that little glitch. Here now you see again the pictures and how things have changed. And you probably also heard that that computer system, database systems have been introduced within the last decades. And they brought one problem with them. That is that we have many systems talking about the same thing. So think about a railroad network. We have signals, we have train tracks, we have switches, which is like an intersection in the road where you can either go straight on or take a turn. And while there is one object, in reality, a physical object, like the signal, the switch out there, we have many database systems talking about it. And those database systems have different aspects of the information that would be relevant to that object. For example, the financial data or technical data. There are many systems, and you probably might know that from your organization as well. These are the things that happen over time. But what do we want? As a user, as a data analyst, as a consumer of data, we want to have one integrated data object which really contains all aspects of the object. You don't really care where the data is from. You're interested in the electronic equivalent of the one physical object out there that you're interested in at that point in time. And for us within our team, the key to achieve this is using an ontology that connects all the data objects in the databases And that translates the meaning and the meta description of those objects, which also translates the relations between those objects. Now, let's have a slightly different look at that. And I also notice that my camera is not working anymore. And here I am again. Hello for those who haven't seen me. So this is our approach. That is basically what I've been talking on the last slide. Imagine we have one object out there, a railroad switch, and there are many different aspects of information across, in this picture, 6 databases. And those 6 databases can be connected in one way or the other. What we end with, once we've integrated things, is the object on the right side. There, you'll find all the information that was scattered around the databases, connected to this one new integrated data object. And you find that some pieces of information like B and C are there 2 times. Why? Because it was there in the databases 2 times. For us, that's a great thing, because it means if the same property, let's say the year in which a switch was built, is the same in 2 databases, it's quite a confirmation that that information is correct. So if both say it was built in the year 2000, that's great. So we have those examples of confirmed information in there, and that gives us a clean, complete, and trustworthy object. However, the system can also, or the situation can also be quite different. In here, you actually find that we have different versions for B. Let's say the year is 2000 in one database and 2001 in another database. After integration, we will find those divergent values on the integrated object, and that alerts us. And we can pass on that information to experts that then, in return, can address the problem at the source and try to see where the problem originated from. Now, this is all a little bit abstract. Let's get a bit risky and try something. Let's try a live demo. This will tell you 2 things. It will tell you a bit more about our integration approach, and it also will show you our GUI that we have developed. And this is pretty much work in progress. So you get a glimpse into our workshop, and the GUI is at alpha level. However, we are quite happy to already use it internally, and you probably will see why. So let's go on with it, but please be patient. Things might go wrong because, well, it's a live demo. What could possibly go wrong? This is the user interface of our GUI. We've connected to a local Neo4j instance, and we've selected a database that contains our sample data. I can enter a Cypher query, and I get a result in the table. Now, if you've been using other tools like the Neo4j browser, you already might notice a difference, and that is that the objects like A and B are here as a little link. And if I hover over it, I can get a preview into that object, which happens to be a node here, which has the ID 52, which has a position, middle. I'll come to it, what that means. It has a namespace. And that holds true for all the objects. Might it be a node, or might it be a relationship? Of course, a table is not all and everything. We might want to see those objects as a graph. Having a graph like that means usually, at least for us, that we start to drag objects around. It is a bit easier if you use a force-directed graph. You already get the idea, that maybe those are two data sets of sorts that are separated. But for us, it still means lots of dragging around things. And so we introduced a new feature, which we call perspectives. Perspectives allows us to arrange nodes, store their positions, store which relations are involved, and restore them so that we then can start working on them. And this is what we see here. This is a very, very abstracted version of the German railway network. We can go from Munich in the south to Hamburg in the north, and as there's a switch we pass, we could also turn and take a right and end up in Berlin. We find two data sets. We find a more geographic-oriented one on the left side, and we find another one on the right side, and I'll come to the one in the middle in a moment. We can inform ourselves, again, about the nodes. We can move the nodes around as usual, of course. And now one thing we can do is, for example, if we find the property position or station name, we can go there and get a description. You find that in the last row. This is the name of a train station, or the position might tell us that it's the geoposition of something. Of course, we used a string here, not numbers, to make it a bit more easy to understand. And the same holds true for the switch. We find that it has a label switch, and we can inform ourselves what does switch mean. And again, at the bottom, you find it's a one-point switch. Okay, let's have a look over to at the data set that is located on the right. There we have pretty much the same situation, only that things are named differently. Here it is station number 3, effectively the node that represents Munich, because in that other data set, in that other database, they decided to use station numbers. We can again ask what is a station number, the number of a station. The same holds true for those other stations. Now, what about the switch in the middle? Here you see that we actually have 3 points describing a switch. The point, the starting point, this is where you enter the switch, and you can either go straight on, which is called the chunk, or you can take a turn, and then you exit the switch on the branch, taking you effectively to Berlin. Now, what we want to end with, that's what we've said, is an integrated situation. So this is what we get in the end when we integrate the data. Here we have the geoposition and the station name from the left side. We have the station number coming from the right side. The same for Berlin and for Hamburg. Now, what about the switch? For the switch, I change the styling. I can do that up here. And you see that this node has become more visible. This is a collection node, which basically contains those 3 points and is an aggregation on a level that allows us to connect that switch and that switch, or integrate it into this switch. Now, how is that really possible, or what's behind that? Let's have a look at another perspective. In here, you again see that we have a data set on the left, a data set on the right, and the integrated data set on the middle. Let's have a quick peek at the left side. I find the nodes a little bit too big, and I can also decrease the font size, and I slightly rearrange things over here to make it a bit more visible. For example, you have down here Munich, which is a main station. It is a main station because it carries the label main station. Now, within the same database, we have nodes that describe the label main station. This is up here. This is what we call a meta label. A meta label contains information about the label that can be used in the actual data. So the description that you see here in the last row, main station and location, is what is displayed down here if you wonder what's happening. It's really showing the same node. Now, the node down here also had properties position and station name. You find position and station name here. These are what we call meta properties. Again, it carries a description, but it also shows where it can be used using those relationships. So a position can be used in a switch as well as in a main station. A station name can only be used in a main station. And you see that those nodes are connected using a railroad as the relationship type, and this is defined over here. We have a meta relation, and the meta relation again describes the relationship type, and in here we have a little helper called restriction, which allows us to decide which labels can be connected to what other labels using that relationship type. Now, we have the same thing on the right side. It's slightly more complicated over here, but you see that over here we have the computed switch, which contains those other labels or meta labels, and you find that reflected, as we've seen before, on the instance level. Now, the last thing that really is missing, I'll show you again in another perspective. This just shows the meta level we've just seen. So you find the description of a main station and a switch on the left side. You find the same on the right side. Now we have also a model which integrates and translates those two things. And again, I can use a different styling, and here it becomes obvious what the secret sauce is. We can draw connections and say an integrated switch up here is the same as the switch on the left side, as well as the computed switch on the right side. And this is how we know that things are equivalent. Of course, we need much more technology, and we have that technology to really then on the actual data level integrate things. But this is the working of the ontology, and that's what's behind it. Now, if you're interested in more details about how this integration really works and how that grammar works, we can tell you. So we have the description of the grammar in the database itself, but I think that's going a little bit too far. I'd rather show you one or two more features that we have in our system. One thing which I find extremely useful is that we can also see the information in the nodes, and we can edit things. We can edit the values, we can add properties, we can edit the labels, we can change that. But we cannot only work with existing nodes, we can also add information. For example, imagine we have Cologne, another city in Germany, and we want to connect that to that switch. We can just do it by using drag and drop. And you see in here that it now has a relationship of the type fix me. If we don't like that, we can again change that, and we get a selection of predefined types that might make sense here. So I use the railroad type, and now you see how it has switched over to railroad. We can also add other objects. We can also choose, let's say that really a new object should be a main station and it has the same color. We can connect those, or as you've seen from other ideas, we can easily create new objects and their relations at the same time. One last feature that might be interesting is that we can change the sizes of things, which in itself is not incredibly smart, but it might be interesting for you to know that we actually have adopted the grass files that you usually use for styling, and we've introduced the possibility to embed Python to do those kind of calculations on the fly as we please. With that, I want to finish the live demo and would like to come to a last question, and that is open sourcing the GUI. We are already a contributor to open source software, and you find the GitHub repository on up there on the right. Now, the big question is, because we are contemplating open sourcing the GUI, would that GUI be useful to you in your organization? Could you work with it? Is that something that's interesting for you? So our honest question to you is, or request maybe, if you're interested in this GUI, please write our team an email. You find the email here, or contact us during the rest of the conference or at any point later in time. Send us an email and we get in touch. With that, I'd like to thank you for listening. And if you have any questions, please ask them now. Thank you.